Okay, so in this video we are moving on to solving simultaneous equations by elimination, and we are starting with linear equations first. Okay, so no quadratics involved whatsoever. So the elimination process is basically getting rid of the x's or the y's so that these equations become solvable. At the moment we can't solve them because we have two variables that are unknown. We don't know what x or y are, okay? But as soon as we find one value, we can find the other. So I'm going to label these 1 and 2, okay? And the reason for that is so that we can let the examiner know what we're doing as we are using these rows, okay? So the first thing we're going to do to start off this elimination process is to decide whether we want the x values to match, so the coefficients in front of x to match, or the y's. I'm going to change the y's. So what I'm going to do is I'm going to think, what number is in the 3 and the 7 times table? That's 21. But if you change one value in the row, you have to change everything because otherwise they're no longer equivalent. Okay, so I'm going to times that top row. Well, 3 times what makes 21? That's 7. And 7 times what makes 21? 3. So I'm going to multiply the whole of the top row by 7. So 8 times 7 is 56. And then I've got 68 times 7, which is 476. Then I'm going to change the bottom row, so I'm going to multiply the whole of the bottom row by 3. So I get 15x and then 189. Now, because even though they're equivalent, I've still got different rows here, okay? So I'm not going to start writing things to the examiner like 1 times 7 and then 2 times, so that's a bit complicated. So I'm just going to relabel these A and B. Just makes it a little bit easier to tell the examiner what we're going to do with these two rows, okay? Now the point of making them the same, if I take these two away from each other, so 21y take away 21y, it vanishes. I've eliminated the y's. But don't forget that if I take these two away, I have to take these two away and the answers as well, okay? So I'm going to do row A minus row B. So 56x minus 15x is 41x. 21y take away 21y is nothing. And then 476 minus 189 is 287. I want to find 1x, so I'm going to divide both sides by 41 to get x equals 7. Once you find one of the letters, which is x, I can now substitute that into either equation 1 or 2 to find y. So I'm just going to stick with the top one, so equation 1. So 8 times 7, add 3y equals 68. And then we're just going to solve. So 8 times 7 is 56. Add 3y equals 68. I'm then going to take 56 away from both sides. So I get 3y equals 12. And then I'm going to divide both sides by 3 to get y equals 4. Now what you can do to double check that you've got the right two values is if you plug in x and y, so if you substitute that back into equation 1, you should get 68. And if you plug the same values into equation 2, you should get 63. If you don't, I would go back and check for numerical errors, okay? But if they work, when you sub it in, you do get 68 and 63, you've done it right. Okay, so let's have a look at the second example of elimination because this one involves negatives. Now, what I would suggest if you're ever dealing with negatives, when you're deciding which values to make the same, the x's or the y's, always go with the things that are completely positive. So the x's both have positive values. The reason that I say that is because then you're always subtracting the rows away from each other. But if you change these two, you've got to think, well, the point of making them the same is to eliminate them. So am I going to take the rows away or am I actually going to add them to get them to balance to make a 0? By always changing the positives, you're always subtracting, okay? So I'm going to turn 9 and 5 into 45, because that's in both of their times table. I'm going to multiply row 1 by 5 and row 2 by 9. Okay, so again, remember, if you change one element of an equation, you have to change every part of it. So I'm going to multiply the top row by 5. And then I'm going to multiply the bottom row by 9. Okay, so again, because I've changed the values, well, the digits anyway, I'm going to turn that into A and B. And again, because I changed the positives, you're looking at these two, and now the only way to get rid of them is to subtract them. So I'm going to do one minus the other. Now, because row B tends to have slightly larger numbers, I'm actually this time going to say that B take away A is the process I'm going to go with. It doesn't matter if you do the other way around. You'll get the same answer. It's just you might end up dealing with negatives, which isn't a problem. So I'm going to do row B minus row A. So 45x take away 45x vanishes. Now, because I've got negatives, they can be quite fiddly. So I'm actually going to write everything down. So I'm going to do 27y subtract minus 20y equals 306 minus 165. Double negative makes a positive. That's just a single negative, so I'll keep that as just one negative. 27y add 20y is 47y. And then 306 minus 165 is 141. And then I'm going to work out 141 divided by 47, which is 3. So y equals 3. And now I've found my y, I'm going to plug it into one of the two originals, 1 or 2. I'm actually going to go with 2 because everything's positive. Make your life a little bit easier where possible. So plugging that back into 2, 5x plus 3, and then I've just found y to be 3 equals 34. And then you solve. So 5x plus 9 equals 34. And then I'm going to take 9 away from both sides. 5x equals 25. I'm going to divide both sides by 5 to get x equals 5. And again, plug y equals 3 and x equals 5 into each equation to hopefully generate the correct answer. Okay, so that is solving via elimination. Now, they could specify to solve by substitution, okay? And it's a slightly different method, but you're essentially still trying to find x or y. Now, the first thing you want to do is, you've got two linear equations here. We're trying to get x equals something or y equals something to then substitute into the other equation. So I'm going to call that 1 and I'm going to call that 2. Now, I can rearrange 2 because I could get x on its own. I could just add y to both sides because it vanishes from this side and it attaches to the other, y plus 1 or 1 plus y. Now, the reason you do that is so that you can substitute x into that first equation, and that's exactly what I'm going to do. So in that first equation, I've got an x there, and instead of x, I'm going to actually add y plus 1. I've got plus 3y equals 18. So you should hopefully notice that we've done something there, comparing this with the original. And that is that the x's have completely gone. Okay, this is now solvable because we've only got one unknown, and that's y. So let's try and expand, collect the like terms, and find y. So I'm going to expand that. So 4y plus 4 plus 3y equals 18. 4y add 3y is 7y. Add 4 equals 18. Let's solve that now. Minus 4 on both sides. So 7y equals 14. and divide both sides by 7 to get y equals 2. Once I find my y, just like before, plug in to find your x, and you could plug it into the second rearranged equation here because it makes things very nice and easy. X equals 2 plus 1 because it was y plus 1, but y is 2. So x equals 3 and y equals 2. Now, if they specify in the exam that you have to solve by substitution or by elimination, you can't pick which method to choose. But if it just said solve, decide what you want to do based on what you prefer to do. You could have, had they not specified substitution, you could have still matched the x's or the y's and done that process. The only reason you would have to do this is, and when I say have to, I mean have to, would be if they said substitution. But if you actually prefer this method and you think, actually this is a preferred method to the other one, as long as I haven't told you which one to use, you can use either. Okay, so that's linear simultaneous equations done.